Hello everyone and welcome, this is Federico. Today I welcome you back to this bytecode series where we analyze Python objects and we try to make sense of them. First of all, I would like to thank you for the immense support that this series is receiving. I do invite you to, if you do enjoy it, to like the video and subscribe and comment about it and new ideas and stuff, because it really does kind of tell me that these videos are appreciated and are useful. I'm happy to make them because obviously I'm learning also a lot by making them, and it's quite exciting stuff. Now today, as the video suggests, or the title suggests, we are going to be looking at generators and dissecting them and figuring out what are the use cases for these objects. Now let's do exactly that. So we're here in our disassemble folder. What we're going to do is actually copy this list file and move it and copy it to this gen.py file. And we're going to use this to compare our previous example. We can get rid of this stuff and maybe this stuff. And then what we're going to do is we're going to create a generator. Now, firstly, I would like to make a distinction between generator functions and generator expressions. So let's have this gen fun. Maybe let me just call it gen fun because these are getting too long. So we have this generator function, which we wanted to do the same exact thing as powers of 2. More precisely, when we wanted to have this kind of structure. So what we can do is for I in range n, we can just simply yield I squared. And this is a generator function, and we will be, let's see what it's doing. So what it's doing is, there's this, first of all, yield keyword, which is quite new if you haven't seen it before. And what it's doing is, instead of where this function constructs the whole list and returns it, in this case, what this generator function is doing is acting like an iterable. So what we can do is say for square in our generator function, and we give it the first the 10 as n. If we print square, we will see that it acts like an iterable. So this is very cool. But what is the advantage of this? Because obviously what we could do is also replace this with powers of 2, and we'd be iterating through a list. This is the exact same, but there's actually a very, very important difference, and the difference comes to the fact with how these objects are constructed. And it's more specifically related to memory management, or to memory in general. What's happening here is you are creating a list in memory, and then you're constructing the whole list and returning it. While here, what is actually happening is that you are giving one element at a time, and then you forget about the other elements. So obviously, if let's say each you have a list of like 100 elements, right? And each element, or let's say 1,000 elements, and each element is like quite expensive, like let's say a megabyte. Well, then this will be quite a large and expensive list. While instead what you can use is a generator, and then you will only be using 1 megabyte at a time, right? And this makes large structures much more treatable, which is pretty much what these generators are for. Now there is a shorthand syntax for this generator function, and we can call it generator expression, and what we can do is just simply do this, which is very similar to the list comprehension syntax, and this does the exact same thing. So whoops, I shouldn't have deleted the bottom line, but this does the exact same thing, right? So if we print square, whoops, it will do the exact same thing as expected. Okay, so pretty much, actually, let's do one more thing. Let's just print what this generator expression is if we just call it like this, just to get an idea. And as you can see, it prints this generator object. In fact, when you just when we look at this expression here, it doesn't really hold a value. It just holds like the information to create the iterable, right? It's just like, you can actually think as an iterable, but just like the initial pointer of the iterable, but it's not actually pointing to an element. It's just pointing to the iterable itself, right? And another thing, what we can do is we can again disassemble it. So if we disassemble this generator, maybe expression, and then we disassemble also this powers of 2 comp. Let's see how they are internally different. And as you can see, they're exactly the same. They are both very, very similar. The only difference is this the way they're being constructed. Here you're actually using this list comprehension constructor, while here you're using this generator expression constructor, right? So very similar in nature, but the main difference is that while the list comprehension is stored entirely in memory, the generator expression, you're only looking at a single element at a time. And let's now maybe look at performance, because I guess that's quite important. So let's analyze this comprehension. Maybe let's create our n again. So we cast it to an int, and it's e to the 7. And let's say we want to calculate the maybe this should be e to the 6, just to not overdo it like last time. So we just want to actually calculate them, right? Actually, let's do it this way for I in, and then we just iterate through them, right? So we want to let's not print, let's just say pass. Okay, and here we do the same thing, right? So we just want to see the performance of these two structures, right? This should be generator, and then this should be generator expression. Okay, and let's see this in action, and it will take a little bit of time, I guess. But now that this finishes it up, you can see that the performance is quite similar. There is some overhead with the generator, because obviously while one is being loaded up in memory immediately, the generator needs some time to kind of go back and get set up again. So there is some overhead with a generator. But now let's look at the memory that's being used. So again, generator expressions are just pointers. So whoops. Well, if we use this module sys, maybe I need to import sys. So maybe it's already imported, I'm not sure. Get size of, and then we get the size of this generator expression, and instead we get this will really drive the point home of what is going on under the hood, right, with these generator expressions. If we do this, and then oops, I guess I forgot to print it. There we go. And then if we run this, we will notice that while this list comprehension occupies, well, obviously quite a lot of I think this is bytes, I'm not sure, in memory, the generator actually doesn't occupy much. And actually what you will see is that if we change n, so maybe here from 6 to 5, let's say, the generator always occupies the same amount of memory. That's again because the generator is just a pointer to, well, I guess like a reference to the generator. You're not actually calculating the elements. You're only calculating them as you request them. And this has a lot of use cases also in functional programming, because with generators you can actually have infinite generators which generate forever. And that's actually perfectly fine, because you will just pick out from them once you need them, right? While list comprehensions, computing an infinite list is impossible, obviously, because, well, you can't, well, because of memory issues and because of time complexity issues. Generators don't have that issue, and what that means is you can come up with pretty clever algorithms which do use generators, which can be of infinite size, and then you can just do that instead and come up with different ways of doing things. And again, in functional programming, this is very, very useful. Generators are extremely useful. And the idea is that generators are kind of a lazy lazy evaluate. Well, they're called like lazy evaluate. You evaluate them in a lazy way because you only evaluate them when you need them. While with list comprehension, you evaluate them when you call them. So yeah, this is the main difference between generators and list comprehension. I hope you found this useful, and if you did, keep hopefully you can support the channel, and see you